about the current system has been gathered, it needs to be evaluated, analyzed, and reported to the people concerned. However, with large and complex systems, these can be very lengthy and hard to communicate the findings of analysis of information systems. A better solution for the analyst would be to write a brief narrative backed by models, that is, a graphical representation of the system. Data analysis makes use of graphical representation for easily and quickly understanding by users and designers. The probability of errors due to misunderstandings and omissions is greatly reduced. One technique that has proved to be very useful is the data flow diagram. Data flow diagrams provide a visual representation of data flow movement within an organization. Data flow diagrams reveal relationships among and between the various components in a program or system. They are an important technique for modeling a system's high-level detail by showing how input data is transformed to output results through a sequence of functional transformations. As illustrated in the figure, it consists of an entity, which is the customer entity. The entity represents people and organizations outside the system. A process, which is shown as receive orders. A process is the action that are carried out with the data that flows around the system. And a data store, defined as orders. Data store is a place where data is stored temporarily or permanently. They are all linked, and this is represented by a data flow, which shows the flow of data to and from a process. Systems design. Systems design is the process of defining the architecture, components, and data for a system to satisfy specified requirements. It can also be defined as those tasks that focus on the specification of a detailed computer-based solution. Therefore, systems analysis placed emphasis on the business problem, whereas systems design places emphasis on the technical or implementation concerns of the system. The process of design begins with a statement of the objectives of the desired system. These are made as explicitly as possible so that the system devised by the designers can be tested to determine whether it meets the objectives of the people who will use it. When the system can be shown to satisfy its objectives, the design process may terminate. During systems design, the analyst focuses on three basic elements: the output that must be provided by the system, the input or source data that the user will provide to the system, and the processing needed to produce the output given the input. Activities in systems design. Design the overall system structure. Designing the system structure means defining its components, the relationships between them, that is, the connections by which control is passed from one module to another at execution time, and the information flows between pairs of modules. Designing the details. This involves the design of the different programs to run on the system, as well as the design of all system inputs and outputs, which include the layouts of all the source documents and reports, as well as other kinds of information displays. The user interfaces with the automated system are also designed at this stage. This may include manual procedures for collecting and distributing system outputs. Design the data stores or database. This entails defining physical storage structures for the logical data structures described in analysis. For example, the decision about where to store all information will depend on the hard disk space required, among other considerations. design the system according to the existing hardware and software environment. The design is then adjusted to the hardware and system software environment in which it will be executing. That is, it is important to keep in mind the existing infrastructure already existing in the organization. Package the design specification. In this step, the portions of the design model are collected in final form into a document, usually as user manual, that will guide the development of the system. Implementation and testing. After the new system has been designed, it is now ready to be implemented. Systems implementation consists of 3 tasks. System development. During this phase, computer hardware is purchased and the software is developed. That means that we actually start coding the program. The major activities carried out during this phase are: acquire the hardware, that is, personal computers and other peripherals, including printers. Build the database, if the system requires one. And develop the software, that is, coding and testing. Testing. Once the code is generated, the program testing begins. Testing is important in order to verify that the system is performing the required tasks correctly and effectively. Different testing methodologies are available to detect the bugs that were left out during the previous phases. Sample data is fed into the system. The processed information is then evaluated to see whether results are correct, that is, whether the output corresponds to what was expected. Installation. During this phase, both the hardware and the software are tested again in the new environment. Although the programmer will find and fix many problems, almost invariably the user will uncover problems that the developer has not been able to detect. Since implementing the new system into the organization involves a transition from an old system to a new one, users should anticipate some difficulties during system start up as they learn their new tasks and procedures. The more these difficulties are minimized through well-designed system interfaces, proper user training, and cooperation among all the participants, the better the transition will be. Maintenance. Software or program maintenance is the updating of application programs in order to meet changing information requirements, such as adding new functions and changing data formats. It also includes fixing bugs and adapting the software to new hardware devices. Maintenance has 2 parts. A systems audit. That is, the system's performance is compared to the original design specifications. This is to determine if the new procedures are actually furthering productivity. If they are not, some further redesign may be necessary. And after the systems audit, the new information system is periodically evaluated. All systems should be evaluated from time to time to see if they are meeting the goals and providing the service they are supposed to. Changes to correct coding or design errors can be made. There are 3 types of maintenance. Perfective maintenance, which is the changing of a system to make it meet its requirements more effectively. Adaptive maintenance, which is the changing of a system to meet new requirements. Corrective maintenance, which is the changing a system to correct deficiencies in the way it meets its requirements. However, a post-implementation review is also carried out so as to evaluate system performance and project performance.